This is the second video lecture on the subject electromagnetic theory. My name is Vikash Ranjan and I am assistant professor of HIT Haldia. Okay, so today we are going to study about rectangular coordinate system. Rectangular coordinate system. So a rectangular coordinate system comprises of a rectangular coordinate system comprises of three line segments which are mutually perpendicular to each other. Okay. So these three line segments are orthogonal in nature. If the angle between two line segments or if the angle between two quantities are 90 degree, then they are called as orthogonal quantity. Okay. So they are mutually perpendicular to each other. The three axes are named as x-axis, y-axis and z-axis. And these three axes meet at a point. These three axes will meet at a point. Let me draw the three orthogonal axes. X, Y and Z. Okay. These three axes are meeting at a point and which will be called as origin. This is the point origin and we represent it with the letter O. Okay. So if a point P whose location is x1, y1, z1, if a point is given to you whose location is x1, y1 and z1, then we can easily find where its location in rectangular coordinate system. So let me show you how to find out the position of point P. The position of point P. Let me draw the coordinate system first of all. X, Y, Z. So now I will show you how to find the position of point P. If it's what is the position of point P in the space if its position is present or if its position is shown for different axes. For example, this point P is x1 units away from origin. This is the origin. So it is x1 unit. So it is x1 unit away from origin. Let me take this point as x1. Okay. Now it is y1 units away from origin in the direction of y-axis. Here it is x1 unit away from origin in the direction of x-axis. Here it is y1 unit away in the direction of y-axis. Okay. So now This is where if if the point P has the location of x1, y1 and 0, means it doesn't lie along the z axis, then if P1 is a point, then this will be the location of point P1 in space. Okay, but we are not talking about the P1, we are just talking about P. So we have z, means we have to travel z along the z axis also, means we have to travel for a z1 unit along the z axis. Okay, so we are traveling, so this is z1. Okay, so this will be the position P in space for the point x1, y1 and z1. Okay, okay, let me rub this and make it in a dotted way, represent it in a dotted way. Okay, so this is the position of P in terms of x1, y1, z1 in Cartesian coordinate system. Okay, now we are going to define one new vector which is called as position vector. So what is a position vector? So a vector, this is OP. Okay, here OP, OP is the position vector. OP is the position vector. So any vector, any vector drawn from origin to point P present in space, then that vector will be called as position vector. Okay. Conventionally, position vector is represented by R. Okay. So this is the position vector. Now, what will be the expression for position vector? R will be written as x x a x y a y z a z. Okay, x a x y a y. Sorry, it will be written as x1 ax, in this case y1 ay plus z1 az. Okay, because this r, excuse me, so let me simplify this expression. Let me draw once again, let me draw the axes once again. This is x, this is y and this is z. Okay, so if this is the position vector, okay, this is the position vector from origin to point P. So how did we get this position vector? What we did, we moved x1 direction, uh, we moved x1 direction, means x1 unit, in which direction? In ax direction. Okay, then we moved, this is x1, the ay direction, this is AZ direction. Okay. So this is Y1. So we moved X1 unit in the AX direction, then we moved Y1 unit in the AY direction or Y direction. So the vector summation of these two line segment will be this one. Okay. Now let me make this waveform in the way. Now I have to move Z1 unit in the Z1 unit in along Z direction. Okay. So this is X1 AX plus Y1 AY. Okay. So adding Z1 A1 AY cap, we get R cap, R vector R, which is position vector. Okay. So this is how this expression is coming. Okay. Now few formulas which are important and you should always keep in mind is that dot product between similar vectors, unit vector, sorry, dot products between two similar unit vectors, that is ax cap dot ax cap, ay cap dot ay cap, az cap dot az cap will always equals to 1. Okay, this will always be equals to 1 because a dot b is equals to a mod b cos theta. Okay, so the angle between, for example, if I say ax cap dot ax cap, so the magnitude of ax will be 1 into 1 and the angle will be, since they are aligned in the same direction, we are dealing with the same quantity, so the angle between them will be 0. So cos 0 is equal to 1. So the formula will give, so means the dot product between two similar unit vectors will always be 1. Okay, so please keep this in mind. Now what about dot product between two dissimilar unit vectors? This is ax dot, let me write all the equations at one place and I will say, so we have already studied that all the three axes are orthogonal to each other. Okay, all the three axes are orthogonal to each other, x, y, z, which means the angle between them is 90 degree. Okay, the angle between them is 90 degree. So ax dot ay, so let me take this example, ax dot ay, this is 1 into 1, cos of angle between them will be 90 degree and cos 90 is 0. Okay, so if we perform the dot product between two dissimilar unit vectors, then it will always be 0. Okay, now what about the cross product? So if we perform cross product between similar unit vectors, okay, ax cross ax, ay cross ay, and az cross az. Okay, so in this case, if you try to do the mathematics, you will get it will be 0. Okay, and now ax cross ay cross az, and az cross ax. cross product between two dissimilar matrices, or when ax cross is ax cap cross ay cap, it will be az cap. Ay cap cross az cap will be ax cap, and az cap cross ax cross cap will be ay cap. Okay. So these are the formulas. Sorry. So these are the formulas which you should always keep in mind. Okay. Important formulas. So after studying all these things, I like to give one homework to all the students who are attending this video lecture. So the question is, uh, given a is equal to, vector a is equal to 3ax plus 2ay minus az, and b is equal to ax minus 3ay plus 2az cap. Find C, vector C, such that vector C is equal to 2 times of A vector minus 3 times of B vector. And find the unit vector AC and angle it makes with z axis. Okay. So this is a numerical, and it is a homework for the student who is watching this video lecture. And let me tell you that AC over here is unit vector. It is a unit vector for C vector. Okay. And one more thing I like to say, that here we have discussed about position vector. Here we have discussed about the position vector. Okay. So the generalized equation of the position vector, let me write the generalized equation of position vector. The generalized equation of position vector will be x ax plus y ay plus z az. Okay. So what is the magnitude of this position vector? Magnitude will be given by, after taking the mod, and we take the mod in this fashion, we will take the square root of x square y square plus z square. Okay, means we will take the square of, we will first square the x component, then add it to the square of y component, then add it to the square of z component. After doing all the addition, we will take the square root. Okay. Now, what will be the unit vector for this for this position vector? So we have seen that any vector can be written by its magnitude as well as by its unit vector. Here A r cap is the unit vector of r vector, where r is the position vector. Okay. So r is x ax plus y ay plus z az. Okay. Then mod r, it is given by x square plus y square plus z square, and ar cap. Okay. So we are trying to find out the unit vector for the position vector. So ar cap will be x ax cap plus y ay cap plus z az cap divided by under root of x square plus y square plus z square, or we can also write as x divided by under root of x square plus y square plus z square ax cap plus y under root of x square plus y square plus z square ay cap plus z x square plus y square plus z square az cap. Okay, so this this is the position vector, this is the unit vector. Okay, unit vector of r. Okay, position vector. So this is the numerical, or this is the homework which is given to you. So in the next lecture we will solve this numerical, and so this is the end of this this is the end of the second video lecture, and thank you and bye, and we will meet in the next, that is the third video lecture. Okay, thank you, bye.